Imagine a world where the roar of industry wasn't born in the gritty factories of the 18th century, but whispered across the sun-drenched landscapes of ancient Rome. A world where steam, that raw elemental force, was harnessed not by Watt, but by a genius almost 2 millennia before his time. This is the profound enigma of Hero of Alexandria and his impossible engine, the Aeolipile. A device that, dating back to the 1st century AD, stands as a stunning testament to an astounding, almost unbelievable ingenuity. For centuries, historians have grappled with its very existence, a ghostly echo of a technological leap that seemingly vanished into the annals of forgotten history, never to fully materialize into the transformative power it promised. Was this remarkable creation a mere philosophical curiosity, an intellectual parlor trick designed to amuse and astound the learned elite? Or was it, in truth, a tantalizing glimpse into a potential Roman industrial revolution that, for reasons we still debate, tragically never was? Hero's writings, meticulously preserved through the ages, offer us a window into this incredible mind.
They describe in precise detail a rotating sphere, a hollow orb suspended and set into motion, propelled by the sheer, unbridled force of steam jets escaping from nozzles on its surface. To envision such a concept, such a clear and early understanding of reactive propulsion driven by thermal energy in the very heart of classical antiquity, is to fundamentally challenge our conventional understanding of technological progression. This was a truly groundbreaking idea, a mechanical whisper of the future, born in an age we often perceive as largely devoid of such sophisticated power applications. It was a demonstration of the raw, immense power latent within boiling water, a power that would lay dormant, untapped for millennia, only to revolutionize the world far in the future. Ancient Rome, after all, was a civilization renowned for its unparalleled architectural feats and its sophisticated infrastructure. Their legacy continues to astound us. Their vast aqueduct systems, masterpieces of hydraulic engineering, channeled life-giving water across incredible distances, sustaining mighty cities and ensuring public health with astonishing efficiency. Their intricate road networks, stretching for thousands upon thousands of miles, bound an immense empire together, facilitating trade, troop movement, and communication on an unprecedented scale. From the colossal grandeur of the Colosseum to the precision of their public baths and advanced siege weaponry, the Romans demonstrably possessed an engineering acumen that allowed them to build incredible structures, overcoming immense material and logistical challenges with audacious skill. They understood the principles of leverage, mechanics, and fluid dynamics with a sophistication that continues to impress even the most discerning modern engineers. They moved mountains, diverted rivers, and crafted monumental edifices that stand as enduring symbols of human ambition and capability. Yet, this remarkable demonstration of steam power, the Aeolipile, this early harbinger of mechanical might, remained seemingly confined to theoretical texts. It manifested only in small-scale demonstrations, intellectual curiosities perhaps, showcased to an elite few. It never scaled up. It never transformed their society. It never ignited the sparks of an industrial age, as it would later do in a world far removed from the glory of Rome, unleashing an era of unprecedented productivity and change. And herein lies the profound, perplexing heart of our historical mystery, a paradox that begs the most fundamental of questions. Why? Why did a civilization capable of such monumental engineering, a society that built a world-spanning empire, fail to recognize and leverage the revolutionary potential of the Aeolipile? The burning question persists, echoing through the centuries, challenging scholars and fascinating enthusiasts alike. Why didn't the Romans harness this impossible engine for widespread industrial use? Why did this astonishing seed of innovation, this early whisper of a mechanical revolution, wither on the vine, consigned to the dusty pages of history rather than changing the very fabric of their daily lives? There are compelling arguments, each offering a distinct and insightful lens through which to view this tantalizing piece of lost technology, each vying to explain this colossal missed opportunity. One prevailing hypothesis suggests the Aeolipile was fundamentally viewed as an intellectual toy.
It was a testament to theoretical genius, a fascinating exhibit of natural forces, perhaps even a clever party trick. But it lacked perceived practicality for heavy labor. In a world where tasks from quarrying colossal stone blocks to grinding grain, from massive construction projects to the essential transportation of goods were readily and reliably fulfilled by readily available manual and animal power, what incentive existed for an unproven, seemingly complex machine? Why seek a mechanical beast of burden, requiring new infrastructure, new skills, and new risks, when human and animal forms were already available, tried and true, and crucially required no new technological paradigm? From this perspective, the Aeolipile was a marvel of the mind, a triumph of abstract thought, but never seriously considered as a practical tool for the workshop, the quarry, or the field. It remained a curiosity, a conversation piece, not destined for the pragmatic, often brutal world of Roman industry. The empire's immediate needs were met by established methods. The concept of grand-scale, labor-saving machines seemed utterly alien or simply unnecessary when existing solutions were so deeply embedded and apparently sufficient.
This theory paints a picture of a society deeply practical yet perhaps limited in its vision of what technology could truly achieve beyond its immediate existing framework. Another perspective points squarely to the very real technological limitations of the era. While the ingenious concept of steam-powered demonstrably existed in Hero's mind and experiments, building truly robust, large-scale, and efficient steam engines for widespread industrial application was simply not yet developed. Consider the materials available. The metallurgy of the 1st century AD, though impressive for its time in terms of crafting tools, weapons, and decorative items, might not have consistently produced the high-pressure boilers, the precise fittings, the durable pistons, and the intricate valve mechanisms necessary for a truly industrial-scale engine. The ability to cast large, strong metal components without internal flaws, to machine them to incredibly tight tolerances required for efficient steam containment, and to create seals that could withstand continuous high-temperature steam pressure without catastrophic failure. These were monumental engineering challenges.
Such advancements in material science, precision manufacturing, and the understanding of thermodynamics were centuries away. The Aeolipile, in its small, demonstrative form, could function, generating enough force to spin its sphere. But to scale it up, to create an engine that could reliably power a mill, lift heavy loads for construction, drive water pumps on a grand scale, or propel vessels, would have required a leap in material science, manufacturing techniques, and precision engineering that the Roman world, despite its brilliance, had simply not yet achieved. The conceptual brilliance was there, the seed of an idea, but the manufacturing capacity and the foundational scientific understanding for true industrial application might have been a bridge too far, preventing the vision from ever becoming a widespread reality. It speaks to the idea that some ideas are simply ahead of their time, awaiting the parallel developments in other fields to truly flourish. A third, and perhaps the most socio-economically poignant, argument posits a different kind of barrier: the pervasive abundance of slave labor in the Roman Empire.
This perspective suggests that the very structure of Roman society, heavily reliant on a vast, readily available, and economically cheap workforce of enslaved individuals, fundamentally negated the immediate economic incentive for labor-saving machinery. Why would the powerful Roman elite, who controlled vast estates and industries, invest significant capital,
time and intellectual effort into developing complex and potentially expensive machines to replace human labor, when human labor, in the form of slaves, was so readily available and often acquired through conquest. The fundamental economic drivers for innovation that fueled later industrial revolutions, the high cost of free labor, the constant need for greater efficiency to reduce wages, and the relentless quest for increased productivity per worker, were perhaps simply absent or severely diminished in the Roman context. This abundance of an unfree workforce, a cornerstone of their economic system, may have inadvertently stifled the innovation that could have led to a steam-powered society, preventing the impossible engine from ever truly breaking free of its theoretical confines and transforming into a widespread practical tool. The economic model of the empire, built on the backs of its enslaved, may have been the very force that held back its technological advancement in this crucial area, demonstrating how societal structures, not just scientific acumen, can shape the trajectory of history. These compelling arguments, debated by historians and archaeologists for generations, each offer different facets of the same profound enigma. They represent scholarly attempts to rationalize the incredible dichotomy between Roman engineering prowess and the apparent neglect of a truly revolutionary invention. Did the Romans simply not see the potential, blinded by their existing paradigms? Were they technologically unable to realize it, lacking the precise tools and materials for a grander vision? Or did their very societal structure, their reliance on vast human resources, actively prevent it from taking hold, making such innovation economically superfluous? Each theory provides a plausible explanation, yet none entirely removes the lingering sense of what if? What if even one of these barriers had been overcome?
We are left then to decode the whispers of history, piecing together the fragmented echoes of this forgotten marvel and the powerful societal forces that shaped its fate. What pivotal factors truly prevented Rome from igniting its own industrial age? Could the course of human history have been dramatically different, fundamentally altered, if Hero's Aeolipile had been embraced not merely as a curiosity, but as the dawn of a new technological era, reshaping the very foundations of the ancient world? Join us as we journey deeper into these profound questions, exploring the layers of ancient ingenuity and societal circumstance, seeking to understand not just what happened, but why. Because every discovery we make, every untold story we uncover, every forgotten page we turn, is an echo of humanity's great, complex, and often mysterious history, providing invaluable context to better understand our present. What if the world's first industrial revolution was nearly Roman? And what profound implications might that have held for the entire path our civilization ultimately chose?